About 10 millennia ago, we invented agriculture. And everything scaled: communities, cities, complexity. And some historians ask a provocative question: did we domesticate cereals, or did cereals domesticated us? Fast forward, about 100 years ago, we invented programming. Then we started to see patterns, and we extracted those patterns into frameworks. Frameworks help us to scale our application, to build larger and larger applications faster and faster and with larger teams. And now we might ask the same question again. Did we domesticate frameworks, or did frameworks start to domesticate us? I'm Tiberiu Tofan from ING Hubs, and today is about owning our design, about using frameworks as tools and not as the architects of our solutions. And Christian, I'm not against frameworks, and I'm not against Spring, so it's not against Spring. This talk, it's about how to use frameworks as programmers and not as users. I've been doing Java for over 20 years. Back when records were something you played, and generics were cutting-edge innovation, kind of like in Go today. And for the last 7 years, I've been working at ING Hubs here in Bucharest. I also have some goodie bags from ING for the best 3 questions. So please ask after the talk, and you can win something nice. Who is familiar with layered architecture? We saw the diagram also in the previous, in Nacho's talk earlier. So layer architecture is probably the most used architecture style in the world. It has some layer of organization, but what is interesting to notice is that it organizes code by technical concern, not by the business needs of our application. And that's perfectly fine when we have a small application. But as the application grows and we scale, layer architecture starts to show its limitation. Today, I want to show you an alternative. And a good way to scale a large application, I think it's hexagonal architecture. In the hexagonal architecture, the domain stays at the center. And it exposes ports that are the gates to outside world. So we have ports are also another name for interfaces. So we have interfaces that we use from the domain to talk to the outside world. And we integrate frameworks, tools, and other systems using these ports. And around the domain, we have the adapters. So for each technical or business concern that is outside our domain, we have an adapter that implements that interface and help us communicate to the outside world. So it's another, ports and adapters is another way of saying interface and implementation using, as the name suggests, the adapter pattern. And by using hexagonal architecture, we get 3 wins. We decouple our domain of databases, messaging systems, APIs, or frameworks. Sorry, I went a bit too fast. Our application is a lot easier to test because we can simulate the behavior of our authorized system very easy by switching our interfaces with small implementations. And the flexibility to swap any integration or framework by only changing the implementation of that adapter. And if we go back to our layer architecture that we started with, because we started small and we didn't realize that our application will grow so large, we can map our layer architecture into hexagonal architecture by extracting the application. First of all, we can have multiple flavors of integration, both for presentation layer and for database or integration layer. And then we can extract the application and domain layers into a core domain layer, which is technology and dependency free. And then we can extract the integration and the presentation layer in adapters around our domain. So our domain is in the center and surrounded by adapters that helps us integrate with outside world. I prepared a small case study. We have a transaction categorization service. This service is pretty isolated, so we can see here it's our overall architecture. It reads transactions from a Kafka topic, then uses a HTTP request in order to get the transaction category from an external service, which is called merchant directory, and then saves that category for later use in a Postgres database. When a client requests the category of a transaction, it makes a HTTP REST request to our service. We query the database and serialize the response back to JSON to our client. And here, of course, we need to use a lot of technologies and framework. For example, we use Spring pretty extensively. We use Spring Kafka for Kafka integration. We use Spring Data JPA to communicate to the database. We use Spring MVC to expose a controller, a REST controller, and OpenFeign in order to call the merchant directory external service. We can see our service in action. It's being used by a mobile banking application. When we look in our application, we can see what did we spend our money on. And then we can even dive into a certain category and see what are the transactions related to that category. And both these screens translate to REST requests to our service. So we have a REST request to get the bigger view of money per category, and then the transactions for a specific category. First thing we're going to tackle is to build a resilient domain. This means to decouple, isolate, and validate our domain. And we have our application. We can see our domain as a fortress. So the domain is in the middle, isolated by the waters around it. And we have these bridges, which represents the ports that are used to communicate to outside world, and the checkpoints on the bridges, which ensure that only valid data can enter our domain. So it's very important to not be able to build invalid domain data. Our application has 6 modules. I named them by technology mostly, so we can see which integrates what aspect of our previous architecture. We have highlighted the domain, configuration which handles, I don't know, property config, specific framework integration, and so on. Kafka controller, JPA, and merchant directory, you saw them earlier. And of course, the domain is in the middle. So all the dependencies should go to the domain. So it should be impossible for the domain to access these outside modules, because it's the center of our application. There are multiple ways to achieve this. I would say the most secure way is to have different application modules, like Maven or Gradle modules. And you don't add the dependencies in the module of the domain to any other modules of your application. So that would be the most secure way. But when you have a smaller application, in our case, that might be a bit of over-engineering. So we start with just different packages. And we can write tests, unit tests, that ensure that we keep this constraint. In this case, there's an Arch unit test that guarantees that the package domain, any class in package domain, doesn't have access to the other packages. You can also use another modern tool for this is Spring Modulate. With it, you can also enforce this kind of restrictions. And I would say you can also enforce with a similar test that your domain doesn't depend on any framework. So for example, if you use Spring Framework extensively, you might have a test that denies you access to Spring Framework packages from the domain only, of course, because we still need to use the framework somehow. And we will see next how. Ever felt like you're playing a memory game with the parameters of a method, like which is first name, which is last name, and so on? Exactly to avoid this kind of problem and not to memorize ourselves the order of the parameters of a function, we can use the compiler to do that for us. So what we're going to do is avoid primitive obsession. And primitive obsession means using basic data types and don't think only at primitives in Java. Any basic data type, such as, for example, string, that doesn't have a business meaning. So if it doesn't have a business meaning, then I don't know just by looking at it what it means. And there are some specific, here is an example of primitive obsession. We have our transaction data, transaction class, which has a lot of string properties. And here is a classic bug. If we swap two parameters when we call that function, so at call site we don't know which is which, we swap two parameters, and it's a very hard bug to spot, because the compiler doesn't complain, both are strings. And if you do a code review, you usually look at the change code, so you don't see the signature of the function that you're calling. So it's very hard to spot this kind of typos. And what we can do is enhance our primitives with domain-specific types. And in DD terminology, they are also called value objects. So we wrap our primitives into domain-specific type. For example, transaction ID, client ID, amount ID, account ID, amount, and merchant category code in this example. So we wrap our initial string values or primitive values with these classes. And this allows us some further flexibility. So it's not just that we have a type and now the compiler enforces us to keep the order of when we invoke a function. Now we can embed the validation. So if we have a specific validation for that property, we can embed it in our domain-specific type. And now the validation is reusable. If we use this type multiple times, because most of the types are reused in our domain when you call a function or even as properties in different classes, we have the validation reusable in all of them. So by having this validation, we enforce the rule that we talked about earlier of not being able to construct invalid instances. And it's also very easy to test, because we can write specific unit tests, very simple unit tests, only for this validation. If we want to test, if you want to test a validation of a field in a context of a larger class, then you have to test to simulate the aggregate field. So you have to provide values for all the other properties that are part of that class. So it's very easy, it's a lot easier to unit test a specific targeted validation. Why settle for one responsibility when you can have them all in a single interface? So let's try and win an inheritance contest. I'd say this is a joke. The next principle is exactly opposing that, so I want to talk about interface segregation. And if you have large interfaces with a lot of methods, then clients of that interface are forced to depend on methods that they don't use. So we create coupling that we don't need. Also, clients of that interface, when you try to implement a new feature, you might be tempted to use methods that you have very close at hand. So because you have a lot of methods there, you said, I already have this interface as dependency. Let's implement also this feature. And you get a lot of code that's being written out of inertia because I have that dependency. And as an example, for our application, for our transaction categorization service, we wrote a categorized transaction repository, which is a JPA repository to interact with our Postgres database. And we have some ways to query our data. So we have multiple ways to query our data. And we say, OK, it's just a simple interface. I only have 4 functions, not that bad. Then we want to use this interface in our service. And OK, I don't want to look at its documentation again. It should be straightforward. And I call repository dot, and I'm waiting to see suggestions. And actually, I see that I have dozens of functions available. And OK, I see the ones that I defined in the top, but I inherited a lot of functions from JPA repository. And actually, I need one of them because I need the save function from there. It's very hard to spot where save is. And this is exactly an example of depending on functions that you don't actually need. My repository only needs 2 functions. Find by transaction ID to see if I already categorized that transaction, and save in order to save a new category. Also, when testing, who likes mocking? I hope to convince you otherwise by the end of this talk, but yeah. Mocking the complex interface that we have, the repository, takes a lot of more code than actual testing. So the assertion would be a line of code, but we have to write 20 lines of code in order to mock our dependency. And this is where interface segregation comes into action. What I want to suggest instead of using directly the Spring repository interface, is to extract only the functions we need from that interface into our domain. We talked earlier about ports. Now we see what a port means. For example, we need the save function from JPA repository. It's there somewhere. We bring it to our domain, and we convert it into a function interface. So we say, for example, save categorized transaction. And we do the same for all the functions that we actually need, because from the 30 functions that the repository exposes, pretty sure we're not going to need more than 10 of them, for example. Let's do the same with find transaction by ID, the functions that we define. We bring it to our domain. We create a function interface that will define our domain interaction with that function. And we can notice that we did more than just wrapping that method in a function interface. We change its signature for a bit. Instead of categorized transaction entity, which is data, it's a Hibernate JPA entity, so an object-related relational mapping entity, we use our own domain type, categorized transaction. It has nothing to do with the database, and which is immutable, because our domain can be immutable, having no framework dependencies, no reflection happening over it, no proxying, and so on. It's a lot easier to keep your domain immutable. Also, instead of the string transaction ID that we have in the repository, we can use our domain-specific type that we defined earlier, transaction ID. And because now we have a type in the signature, it's not string, it's transaction ID, it's redundant to call the function find by transaction ID because the parameter says it all. And we can call our function only find by. And we can also overload a lot of find by functions because they have different parameters. In the previous example, we cannot have find by with string account ID as parameter and find by with string transaction ID as parameter because the name of the parameter has business meaning but has no meaning to the compiler. And a common concern when splitting into that many function interfaces is that I'm going to end up with a lot of implementation, a lot of classes, hard to see where is that functionality and so on. But the good news is that we don't have to have as many implementations, one-to-one correlation with the function interfaces. We can have a single, and now we can say the term adapter, for all our ports related to this repository. So we have the flexibility of choosing how we split our implementation. In this case, we have a single adapter. We can also have adapters, for example, focused with, for write and read. There are multiple flexible ways of splitting the implementations. And the adapter, all the adapter does, it delegates the actual database queries to Spring JPA repository. So it adapts between our domain and Spring JPA repository and also converts any domain-specific types to the type that the database expects. And then in our services, we are able to pick and choose which functions do I actually need in order to do my business rule. So in this case, I need to see if I already have a category and save a new category. And even though I have two function interfaces, I have the same adapter for both of them. And if I use Spring for dependency injection in our infrastructure layer, so this configuration class would be in our config module that we talked about earlier, then we can inject the same adapter in two places. So we use the same instance to replace two different ports that we use here. And there are situations when maybe I need a lot of functions. So there are, usually it's a cold smell. So if you see that you need a lot of dependencies in order to do your business, then maybe you're trying to do too much. But there are valid use cases. For example, in a REST controller, I might present data in a lot of different ways. And I would say that it's perfectly fine there to use a lot of repository functions in order to query your data. And for this, we can use generic dependency injection. So we could have a generic type R that extends all the ports that we need, all the function interfaces. And what's really cool about this is that, for example, if you use Spring as a dependency injection framework, but not only Spring, they know to substitute this generic type. So because we have a single adapter that implements all these function interfaces, Spring knows how to inject it in our constructor. So we don't have to do basically nothing. Only define our type and choose which implementations we need. Of course, all of them have to be implemented by the same adapter. So we have to have a type that fits R in our type system. And now, if we try to implement our query function, we don't have surprises. We only have the functions that we picked. So no dependencies that we don't need. Remember our complex mocking setup? Now we can do better. We can use functional interfaces, lambda expression, to define the behavior that we need for that specific test. So we don't need to do any mocking anymore. Here is another example. We do exactly the same for the HTTP client that we're implementing. I will skip over it because there's not much time left. And the third principle that I want to tackle, very shallow, because there's not much time, is throw exceptions out of your domain. And what I mean by this is isolate exceptions in the infrastructure layer. So in your domain, use first exceptions, possible errors, business errors as first-class citizens. So define them as classes. Ideally, since Java 17, we have serial interfaces, which would also enforce you to handle all the possible outcomes, and use a type as either or result in order to specify explicitly what can go wrong. And the key takeaways would be to keep your domain safe, to segregate interfaces into small functional interfaces, avoid primitive obsession, because using domain type, we get the help of the compiler to do the memorization of what each property means. First-class errors, model the domain errors as first-class citizen, as classes, and enforce domain integrity. Decouple from infrastructure and framework, isolate and validate. You can find the source code for this project here in GitHub. Any questions? I have goodies.
Thank you very much, Tibi. Maybe one question if you... OK.
Hello.
It will be a difficult one. I know the guy.
So I like it on the database layer, what you did. Can you also show how it works with in the controller in the other side of the controller, right? So are you able to serialize and deserialize JSON objects easily with this pattern?
Actually, I used Spring for that. So that's why I said nothing against frameworks, just how you use them. Here is a classic Spring controller. So I have a direct deserialization in my and serialization provided by Spring MVC.
OK, and, but you have like a string, right? So you're using string here.
Yeah, OK, I have a string client ID. You mean the parameters?
So maybe you can show like a post method where you create a complex object.
I don't have I didn't prepare the project. You can find it on GitHub. So there's a working solution implemented by this method. And I also have I refactored that from layer to hexagonal. So there's also a PR in GitHub where you can see the difference between the two approaches.
So what I don't like here, what I'm seeing and I don't like, is that you have to write a new client ID of client ID and new and expense category of category. This is what I don't like. And
oh, yeah, this is where the conversion, yeah, this is exactly the conversion between primitives, so basic types, string in this case, and domain object happens. So new client ID creates a new domain object. in order to, when I use that repository there, it's not the Spring repository. So our controller doesn't depend on Spring repository, but depends on the domain repository. And the domain repository offers functions that have that are in the domain. So basically, the domain here is used also as an indirection layer between the controller and the database. So also different, if we remember hexagonal architecture, having everything around our domain, different integrations don't communicate directly one with another, but using the domain. And this, because of this, if I replace the technology, I only replace an adapter.
Okay, I guess we will not have time for more questions. I saw the hand, but I'm sorry, we need to cut it short because I'm pretty sure, and I see on your faces that you're hungry as well. But again, I do encourage you to grab the speakers also in their spare time between the talks, and you can ask them more details. Thank you very much, Tibi. One more round of applause.